Graphs of data pairs for real-world situations rarely fall in a line. Their arrangement, however, can suggest a relationship that you can model with a linear function. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. You can use a scatter plot to determine the strengths of a relationship or correlation between data sets. The closer the data points fall along a line, the stronger the relationship and the stronger the positive or negative correlation between the two variables. So consider these images, scatter plots representing different types of correlation. First, on the far left, we see an example of a strong negative correlation. Notice there seems to be a strong downward trend to the right in these points, and they might fall pretty well along a straight line. Next, a weak negative correlation. So these points still seem to trend downward and to the right, but they wouldn't fit as tightly to a single line. In the middle, no correlation. We kind of have a bunch of points scattered about, not really fitting any sort of trend line. Next, a weak positive correlation, similar to our weak negative correlation, but trending upward and to the right, suggesting that as one variable increases, the other one also increases. And then finally, a strong positive correlation where they do fit better to a single line. Problem 1, using a scatter plot. Utilities. The table lists average monthly temperatures and electricity costs for a Texas home in 2008. The table displays the values rounded to the nearest whole number. Make a scatter plot. How would you describe the correlation? Well, consider the table. We have average temperatures and electricity costs. We have January, February, March, all the way through June on the table at the left, and looks like the rest of the calendar year on the right-hand side. And then we have two columns in each table, average temperature in degrees Fahrenheit on the left, electricity bills on the right in dollars. Step 1, make a scatter plot. So what we'll do is we'll extract the points, letting average temperature fall along the horizontal axis or the x-axis, and then the electricity bill along the vertical or y-axis. And as we extract points in January, 61, 150, if we think about that as an ordered pair, we can plot that as a single point on the scatter plot, and then continuing through, plotting the rest of the points for February through December on the same plane. Now all these points are our scatter plot. Step 2, describe the correlation. Well, as the temperature increases, the electricity cost also increases, which seems logical. The points are relatively tightly clustered around a line. So there's a strong positive correlation between temperature and electricity cost. Your turn. Part A. The table shows the numbers of hours students spent online the day before a test and the scores on the test. Make a scatter plot. How would you describe the correlation? And Part B. A reasoning item. Using the graph from problem 1, how much would you expect to pay for electricity if the average temperature was 70 degrees Fahrenheit? Explain.